Hello, I am pleased to welcome UVA alumni, parents, and friends here today to the Future of Autonomous Vehicles. This event represents a collaboration between the UVA Office of Engagement and the School of Engineering and Applied Science. Before we begin, I want to note that this event will be recorded. If you have questions you'd like to submit to the panelists, you may use the Q&A function at the bottom of your screen throughout the presentation. Our panelists will try to answer as many questions as possible after the main discussion. My name is Brian Smith, and I'm the chair of the Department of Engineering Systems and Environment, home of Civil and Systems Engineering at the University of Virginia. I've been on the faculty at UVA since 1998, and I am the former director of the university's Center for Transportation Studies. I've taught a wide range of classes, ranging from transportation engineering, engineering design, system engineering, geographic information systems, and construction management. My primary research interests are in transportation system engineering, focusing primarily on connected and automated vehicle systems and other areas of advanced technology applied to transportation. I've also published transportation-related research in the areas of cooperative systems, probe-based traffic monitoring, statistical modeling, traffic flow theory, and artificial intelligence. I'm very excited to have the opportunity to speak with our two panelists today. And at this time, I'd like to invite both of them to turn their cameras on for introductions. So first, I'm pleased to introduce Jiajun Zhu, president and founder of Nuro. Jay-Z is a co-founder and CEO of Nuro. Nuro is a robotics company that develops autonomous delivery vehicles to transport goods. Recently, they have partnered with national brands such as Kroger, CVS, and Domino's. Previously, Jay-Z worked as a principal software engineer at Google, where he worked on the self-driving car initiative Waymo. In 2020, he was selected for Business Insider's list of the 100 people transforming business, LinkedIn's top professionals 35 and under, and Forbes 40 under 40. He earned a master's degree in computer science from UVA and his bachelor's degree from Fudan University. Please also welcome Neda Cvijetic, Senior Manager of Autonomous Vehicles at NVIDIA. Neda works on autonomous vehicles, AI, and computer vision at NVIDIA, and also is a producer and host of Drive Labs, a video and blog series, a behind-the-scenes look at the range of AI and AV technologies under development at NVIDIA. Previously, she worked on advanced projects in autopilot and infotainment systems at Tesla, served on the adjunct faculty of Columbia University, and held senior research positions at NEC Labs America. She holds over 20 granted US patents, as well as peer-reviewed conference and journal publications with more than 4,000 Google Scholar citations. She earned 3 degrees from UVA, a bachelor's, master's, and doctorate in electrical engineering. Thank you both for taking the time to speak with us today. I'd like to start off by asking you both to give a brief overview of the exciting work you're doing right now in your respective companies. Neda, do you mind kicking us off?
Yeah, absolutely. Thank you, Brian. Thank you for organizing this. It's great to be here and great to be on this panel today and talk with Jay-Z and you as well. Yes, absolutely. So at NVIDIA, what we do is that we are a platform company. We basically provide solutions that enable anybody that's building a machine to make that machine AI enabled, capable of artificial intelligence, and capable to be autonomous. And this is a very sophisticated, complex problem, and it reaches the entire stack, from the actual hardware, the supercompute hardware that you need to basically perform the computations that allow these AI and autonomy functions, all the way up the software stack, whether it's the operating system, middleware, algorithms in perception, how the machine sees the world, mapping, planning, all the way up the stack. And we are happy to support our partners. We have an ecosystem of hundreds of different partners, from startups all the way to large automakers, to academic and government entities, however much or however little they would like us to do that. So we invest in the entire stack, in the infrastructure as well. And that is what we're working on at NVIDIA in a nutshell, the 30-second version.
Great, thanks, Neda. Jay-Z, would you mind giving us a background on your work?
Thank you, Brian, and thank you for organizing this event and inviting me. And I'm really excited to be here with everyone. So Nuro is a robotics startup. We're in the Silicon Valley, and we started about 5 years ago. Our mission is to accelerate the benefits of robotics for everyday life. So our goal is to build robotics product that could really save time, give people time back, and then give people time, more access to goods and services. And the first product that we built is a fully autonomous goods transportation vehicle. And you might have seen it in most of the most recent ads. It was Domino's. We built a fully autonomous vehicle that drives on public road and it doesn't have passengers, occupantless vehicle. It delivers grocery, pizza, food packages, that's the first product that we're building. And the longer term in the future, we are also thinking about other type of robots. For example, eventually, I want to build robots that does cooking, folding laundries, and things like that that just help us live everyday life better. And we are also a customer of NVIDIA. So thank you, Neda.
Thank you, JZ.
Great. Thanks for those overviews. So my next question is can you provide a layperson's explanation of some of the science behind how these autonomous vehicle technologies work?
Who should start? Yeah, you want me to? Okay, sure. Yes, absolutely. So at NVIDIA, we are very artificial intelligence based in the way that we tackle the problem from the technical perspective. And the way that I would really make that distinction as far as what artificial intelligence does, for example, in an area like computer vision, where the machine, whether it's a robotic delivery robot or a mass market car, sees the world, is that when I was at UVA back in the day, a lot of these vision or image processing algorithms, an engineer would figure out how is this algorithm going to extract features from the image. I'm going to take a gradient here, then I'm going to threshold this, then I'm going to take an inverse, then I'm going to draw a histogram and integrate this area, and then I'm going to figure out what's in this image. So a person would sit there and basically engineer how we would extract information, visual information from the image to understand the world, for the machine to understand the world. What's different with artificial intelligence is that we move away from that because this problem is too complex. There are too many corner cases, too many variations in the environment, in the operational design domain. And we say, we're going to just take a lot of data, we're going to label that data, and we're going to let this neural network that mathematically represents the operation of the brain automatically figure out what visual features matter to the problem at hand. And in about 2012 is when, the computer vision community saw that this approach can actually provide better results than if a human was sitting there and hand engineering every single computer vision aspect. So I would say that that's the key thing that's different. The data now is writing the software more directly, which is why the data matters so much. And I think we're going to get into this later in the webinar. But really what I would say is the key difference here is that the data pretty much writes the software in the way that we do things with the AI-based approach.
Yeah, very, very much agree with that. And I'll add that, so if you look at the entire autonomy system, every robot is basically an autonomous system. So there are some similarity in the autonomy stack. And usually the autonomy stack is trying to solve a few problems. The first one is where am I? Where is the robot? And there are many different approaches to that problem. And the second one, as Neda mentioned, is to use machine learning and data, the latest data-driven AI approach to really help perceive the world, so you understand what's going on in the world around you. And in this case of autonomous vehicles, we want to know the state of traffic lights. We want to know pedestrians around us, cyclists around us, other vehicles, how fast they're traveling. So this is a really important part is the perception part of the world. And then the next problem that we usually want to solve is what is the world going to look like in the next few seconds, so that I can anticipate what other pedestrians or vehicles will do in this world. And then the last one is, what am I going to do, from a robot perspective? So this is kind of high level overview of what autonomy system looks like in general. And every company has different approach at solving this problem. There are similarities and there are unique aspects of different companies' approach. But I would say that in general, when you look at autonomous vehicles, or if you look at robotics systems, they usually follow this breakdown.
Thank you. The next question I'd like to ask is, in your work, how do you make the case for autonomous vehicles in order to build people's trust in these new systems? Neda, why don't you start?
Sure. So one thing that I noticed, a few years ago is that oftentimes when people talked about AI, they would almost be a little bit anxious about it. Like it's this mystical black box, some sort of black magic, doing things in ways that we can't fathom, that a regular human can't fathom. But then now this goes inside the car and this car is now going to drive you, right? So there is a little bit of, lack of understanding there that we wanted to completely dismantle. And so the way that we do it actually is that we completely take people behind the scenes. We actually say, here are the algorithms that we're building. Here are the networks that we're building. Here's how they come together into these three components that Jay-Z mentioned: the perception, the localization, the knowing where you are in space, the planning, what you're going to do about it, just being completely transparent about what we're doing. And this really was the beginning of Drive Labs. We wanted to change the conversation in the industry about how we talk about this, empowering everybody who is going to get in this car to understand how it works. Because I think it's through understanding, that somebody feels comfortable and now willing to engage. And so to us, making this accessible, democratizing the understanding of AI, the understanding of the technology behind autonomous vehicles is tremendously important and is a key way that we've gone about it.
Yeah, I think Neda mentioned like how the industry is doing a lot of work to help the society understand autonomous vehicle technology. And I think just to add on to that, one thing that we do at Nuro is we build custom vehicle. So the vehicle is pretty unique, right? So for example, this vehicle doesn't have any seats in it. There's no occupant, there's no driver, no passenger, there's no steering wheel, there's no brake or gas pedals. So it is completely designed from scratch for moving goods. And I would say that one thing that help us is for our customers to try our service. They tend to be more open to trying our services. We've seen a wide range of background or occupation or experience from our customers that they feel really safe and completely natural when it comes to using autonomous vehicles for goods transportation for delivery. So I think that is perhaps one of the many things that the industry can do to help bring autonomous vehicles to our day-to-day lives. And once we see more of these vehicles on the roads, I think people will get more used to it.
Thank you. So the next question I wanted to ask is about data, and data governance has been a controversial topic in the last decade. With this automated vehicle technology that is constantly collecting data, how are you considering the ownership of data during your development? Jay-Z, why don't you kick us off this time?
All right, sounds good. So we do collect a lot of data, but I think like pretty much everyone in the industry, we treat this data very, very thoughtfully. We don't share this data publicly. So unlike maybe if you were to draw any comparison, say Google Street View, right? They collect a lot of data, but they also publish this data on the internet. So there's probably more concern about, privacy, safety and all that. But I think for autonomous vehicles, because we're just collecting this data to help the AI do a better job in driving vehicles, a lot of these data are stored in the cloud. Most of the time, no human ever look at this data. It's mostly just machine looking at the data. I think that's a pretty big difference. And also, as you could imagine, that we will have tens of millions of these robots, these autonomous vehicles on the road. Eventually, they will be collecting data, every second, every minute, every hour. It's going to be tremendous amount of data, and it's pretty important for any algorithm or any system. In order to make use of these data, we actually only pick those that are most interesting. And this is also something that that would also provide another level or layer of kind of protection on top of all the raw data that we collect. So from a kind of a technical and also maybe business kind of use case perspective, I think I believe the public should have much less concern about the data than than other type of internet service where data is disclosed or published on the web.
Thanks, JZ. How about you, Neda?
Yeah, I agree with Jay-Z's observations. I would also say that, at NVIDIA, we pay also a lot of attention to what regulatory bodies, whether it's in Europe or in the United States, or standardization bodies are recommending, not just in terms of data privacy, but also ethics in terms of bias. There are standards now being developed in EU that if your product is somehow biased, if you can't prove that it's unbiased, you can't sell it in the EU. So in some sense, there are regulatory frameworks also coming online to help ensure that folks developing applications in this data-driven space are doing so in the right way. So from the legal perspective, we are closely paying attention to all of these things. We have our own internal committees on AI trust, on AI ethics, on AI bias, and eliminating that. So we pay a lot of attention to that. And from the technical perspective, I would echo what Jay-Z said about finding the most interesting data or the right data, if you will. It's really, really important, again, to echo this point of data writing the software, to know how to choose your data and to treat that data with a lot of integrity in the way that you select it, in the way that you store it, in the way that you label it. Because ultimately what we're going to have to prove, both for ourselves doing rigorous high integrity work as engineers, and also because of these regulatory bodies, is that we can reproduce these results. They are traceable. They are explainable. At the end of the day, we're working with machines that can move very fast. And so having that ability to have repeatability, to have explainability is incredibly important. And ultimately, it starts with the way that you collect and treat your data.
Thanks. I just wanted to quickly mention, this is in the chat as well, that if you have questions for our panelists, you can use the Q&A box at the bottom of your screen. I see that we have a number of questions coming in already, which is great. So Neda, you started to talk about legal issues. I guess I would just ask, are there other legal issues that you've had to work through in order to continue developing your technology?
I would say that this is one area where the industry really is now seeing a lot of activity, both through the regulatory bodies, both here and abroad. And so I think that really what is inspiring us to do is to apply all the best practices we've seen from other industries from the get-go to evangelize best practices that we have learned as NVIDIA over the several years that we've been working with this data, and just implement them in the engineering process. So I would say that in some sense, especially in automotive, for example, for mass market cars, where you also have things like compliance to, for example, automotive standards, ISO 26262 functional safety comes to mind. Having this awareness from the beginning, right? Because whatever you make at the end of the day needs to be compliant to what the auto industry, for example, is used to in case of mass market cars. It's also sometimes being a thought leader in the space because, for example, with AI, it's interesting, if you have a neural network that has a set of mathematical model parameters and you change those and you recompile the code can be equivalent, but the functionality is different. And so sometimes you have to be a thought leader in how to expand existing standards that may not have taken that into account, to take that into account and to do everything the right way. So I think it's a combination of adopting best practices, both from our own experience and experience of other industries, but also using our experience to provide that thought leadership, because a lot of this in terms of standards and legal frameworks is being developed as we speak.
Yeah, great answer, Neda. The only thing maybe I'll just add for folks who are new to this field is, if you think about the regulatory work in this new field, there are kind of two parts to the product. One is the vehicle. The vehicles typically comes with a lot of innovations, right, for self-driving. So for example, there's like redundancy in steering, braking, and if you're going to remove like steering wheel, right, that is a big innovation in the automotive space. So there's like a lot of regulation on the vehicle itself. And then there's also another part of the innovation here, which is the driver part, which is autonomous driving, the software part. In the US, the federal government, such as the Department of Transportation, NHTSA, they really regulate a ton about the vehicles, and they advocate for innovations in this space and figure out how everybody can do this in a safe way. And most of the regulation of the driver part, the driving part, is at the state level. So for example, California could have a different view on this problem than Virginia, for example. And I think if you look at the federal level and the state level, all layers of the governments are making a lot of progress on this, and the industries are collaborating. And I personally see I don't see any legal or regulatory roadblockers in this industry, although we're not perfectly there yet, but I think we're making lots of progress.
Thank you. So my next question is looking more at the benefits of autonomous vehicles in terms of our transportation system. So we've heard many people talk about the potential for AVs to improve safety in transportation. There are, as we all know, millions of crashes each year in the United States, which has tremendous impacts in terms of health, quality of life, the economy. Others have suggested that AVs have the potential to address some of our problems in terms of congestion and the impact of transportation on climate change. What do you see as the major social benefits that AV technology can bring for our society and our communities? Neda, why don't you start us, please?
Sure. So I think the first one is the one that you said, that there are so many crashes each year. I think the number has actually gone up in the last couple of years, and I think it results in about 40,000 fatalities per year. So that's really the number one reason of all. It's interesting. When I was at UVA, I took Kenneth Elzinga's econ class. I think he's still a legend on grounds. And what was interesting to me that I remember to this day is that, the econ system models human beings as rational utility maximizers, which may be true in some areas of life, but I'm sure we've all seen that not really play out behind the wheel all that well. That utility function, whatever it is they're maximizing, may not be super rational. And I think that that's the part where we are looking to really help as far as safety goes. So this machine is never going to be drowsy. It is never going to make poor decisions behind the wheel. And so, that's, I think, in service of safety. I do think that there are other benefits as well. And I do want to give a shout out to Jay-Z and to Nuro here, because I think what we've seen in the pandemic is that the delivery of goods to people when they're unable to get them themselves is incredibly important. not just, in terms of convenience, but for very practical reasons, getting food when there's a pandemic out there, very, very simple in some sense, but fundamental use case that actually touches on safety very deeply in a very profound way. So I would say that I do see tremendous benefits in that area, even beyond convenience. And then, yes, I think that, as far as other impacts, social impacts and climate change, I will touch on one very interesting thing. I was, on a panel recently, and there was a woman from Ford who was talking about how there are cities where traffic flow is designed to actually optimize routes for paid workers versus unpaid, right? Paid workers take a straight shot trip to the office. Unpaid workers make multiple stops, and these unpaid workers tend to be women historically, and the pandemic has certainly not helped that ratio improve. Actually, we've seen the opposite happen. So if autonomous vehicles can make this better, can optimize the way that these trips are taken, and can basically do this for somebody else who can then spend their time differently, then I think it has not only climate impacts, because the amount of time that people are spending in traffic is less, and the traffic flow is better, but also in these traditional kind of, biased situations that we've seen, whether they're intentional or not, but basically eliminating that gap, because this person that up to that point was spending their day doing unpaid labor in a suboptimal traffic route has now been released by autonomous vehicles to do something else with their time while still getting the stuff done in a different way. So I think that the impacts are really powerful on so many different levels. So to me, that's what's most exciting.
Yeah, I think that was a excellent example, and I'll maybe share one thing that really stuck with me was when there was a TED talk on the power or impact of washing machine. I don't know if you've seen it. So people talk about, washing machine, it gets invented, maybe 100 years ago, so people can get laundry done faster. But it's much more than just saving the time and getting the laundry done. It's when you get that time back. Women's typically who did laundries at that time, they get to read books, and they get to have more education, and then do more things that they like to do. So I think that is incredibly powerful when you think about you're inventing something that could give time back to people. I'll give you one stats that in the US alone, Americans spend 1 million years every year in grocery stores. That's a lot, right? Every year, imagine we're spending 1 million years at grocery store, and imagine if we can do, run errands for people, how much time we can save. So that's just one example. I think in terms of social impact of autonomous vehicles, I think this is kind of along the lines of like giving people more access to transportation. Another thing that is usually kind of ignored by the public is food desert problem. If we look at the US, the majority of the low-income families actually live in food desert. And we really believe that this is a transportation accessibility problem. And once you can really lower the cost of goods transportation, you could solve this problem to a much large degree. And when we did the simulation, just by looking at not just Nuro, but in general, like autonomous vehicles, progressing the ODD, what we call ODD, which is what is the scope of the driving scenarios that you can handle in a very reasonable ODD, which we believe will be tackled very early on. It's almost 70% of the low-income families, they will get their access to much lower cost of goods transportation, which we believe is a pretty big impact that we can make. And also in terms of the environment and the climate, all of these vehicles are gonna be electric, in my view, and I think Nuro is, for example, is building fully electric vehicles, and by our estimate, between 2025 and 2035, just in that 10 years, the autonomous vehicles will be able to, even just for goods transportation, will be able to save or reduce CO2 emission by 400 million tons. And that is a lot. That is almost like the equivalent of the emission that is needed from powering every household in New York City, LA, Chicago, and Houston combined for 10 years. So this is a really, really big impact that we're talking about from autonomous vehicles.
So in your responses, you talked a bit about, certainly the impact of this technology on people. Let's talk about, the advent of autonomous fleets and how that will impact certain job sectors and industries. JZ, maybe you want to start with this one.
Yeah, so we actually did this study. So we worked with a third-party research institute, and they did this research on the impact of just autonomous vehicle goods transportation, and not including the full passenger transportation yet. Even if you just look at the goods transportation, during the 10 years starting 2025, the projection is that this industry will be able to create almost 3.4 million new jobs. This is new jobs in engineering, new jobs in operation, in new jobs in like standing up this new service in manufacturing. And just to give a comparison so that people understand how much is 3.4 million jobs, all public school teachers, that adds up to about 3.2 million in the US today. So this is a very, very significant number of jobs that we could potentially create by creating a brand new industry.
I completely agree with what JZ said. I think the number one impact, if we don't consider individual transportation, will be delivery of goods. 100%. I think one is residential delivery that Nuro is working on. Another one, even on a larger scale, I think is trucking. So this really, long distance delivery that we're seeing, I think is going to be completely revolutionized in terms of the way that business is done. I don't think that there will be job losses, honestly. I really don't. I think we will still need people. We will still need folks working in various areas of the industry. I think the key word that JZ said in his answer, which I think is exactly right, is new. They will be new, they will be different, and there will be plenty of them. But I think that this industry, both through electrification of the machine, whether it's residential or long distance delivery, a super large truck, and then through automation, we will have a tremendous impact for sure.
Okay, I have one more question I'd like to ask before we turn it over to addressing the audience submitted questions. And that is that we're seeing, a lot of coverage of AVs in the media now for different use cases. How far do you think we are from seeing fully autonomous vehicles on the road, and how long do you think it will take for mass adoption to happen? And Neda, why don't you start?
Yeah, so I think that I'd like to go back to something JZ said in his previous answer, and that's the word ODD, and that is operational design domain. And I think that basically that kind of defines the parameter over which a vehicle works. So for example, you can have a personal vehicle that operates autonomously with a human in the loop on the highway in decent weather when lane markings are good. For example, that's an operational design domain. Or you could have a Nuro vehicle that operates at a certain speed limit for residential delivery and under other conditions also. That's an operational design domain. I think that for very concretely defined operational design domains, we are already seeing vehicles working with a human in the loop. Tesla autopilot system is one example. Nuro's work is another example. And I think the way that we will scale is through this way, through a very clear understanding of what the operational design domain is for this vehicle. For example, long haul delivery on an autonomous truck. What does that mean? What is the operational design domain, right? With that clear understanding, I think we're already seeing deployments. And I think through that clear understanding and the increase of that operational design domain to include more and more parameters over time is how we are going to see mass adoption, whether these parameters are weather related, whether they are geography related, whether they're related to the, the speed of operation, basically the physical speed at which the machine is driving. I believe that that is how we are going to see these deployments that we now see happening scale to broader adoption.
Yeah, and Neda, I think I was waiting for you to make a comment on how many years, because I'm really curious to hear your thoughts on this.
I think that's a great question. So what I think that we're seeing is for the years question to me is most concretely answered when somebody has an operational design domain in mind. So when somebody says, in 2024, 2025, we are going to do X, Y, and Z on the highway, for example. And I think that we have seen automakers commit to this. They've committed to electrification, for example, by the end of the decade. And we're seeing them commit, for example, to human in the loop level autonomy that is much greater than what we have today under this operational design domain, let's say within the next 3 to 5 years. These are the types of things that I have seen that to me are most compelling because they are so clear and because I feel the problem is so well understood. I sometimes I'm a little bit resistant to super duper hype. Like, yeah, there'll be nobody driving this car in this crazy urban situation with snow on the ground and a zombie apocalypse, but that's fine. And it's happening next year, right? So that to me is a little bit complex, right? We have to unravel that a little bit better. Like, how do you detect a zombie, for example? But this other scenario where the design domain is clear, that I'm seeing happen even on the 3 to 5 year horizon.
Yeah, I totally agree with you, Neda. I think this is going to be a very long-term project. It's one of the most interesting and profound engineering challenges. I can see that the industry, keep working on this for the next 20 years or even 30 years, or even more than that. It is going to take a long time before we see fully autonomous vehicles everywhere. But as Neda said, I think for specific ODDs and specific use cases, we probably will see more commercial deployments in the next few years, which I think is really exciting. And I should mention maybe one thing is I think, and Neda, you might disagree with me, but I think the industry is not very good at predicting timeline yet, and I think partially because this is a very, very hard timeline to predict. It's not that every company doesn't know and they just want to give you an answer, but it's just really that every year people discover new challenges and new problems, and things take longer than anticipated. So if you follow the news, when people say, maybe 5 years ago, every company says, okay, 2021 will be the time when we deploy self-driving cars, but I think it's it's delayed, and I think but one thing that I'll mention is, having been working on this for more than a decade, I truly see the progress. And every year I feel that the reality is closer. So it's just day and night difference between 13 years ago, like what the autonomous driving technology was versus today, from like hardware, machine learning, data, like compute, like all of these things, just way, way, way better. And I think if we continue this trend, I'm very, very confident personally that self-driving will be a reality at scale, meaning that when we walk out of a building, we're going to see self-driving cars pretty often in this decade. So that's how I think about this.
I completely agree with you. I definitely think that this industry has followed that classic Gartner hype cycle, right? Where it's like, oh yeah, it's coming next year. Oh no, it's not. And so now the final stage is the kind of the plateau of enlightenment, right? I think that we have a much better understanding now about what it takes to commercialize this, right? If you look at the DARPA Grand Challenges, you mount these enormous cameras, they're not integrated, doesn't matter, if they perform and withstand like 10, 20 years over the lifetime of the car. Yeah. The compute was a fraction of what we have. Nobody was thinking about functional safety at the time, but now we have learned so much. And I think we really comprehensively understand how to get this into the market that, in a way that delights customers, but also performs to expectations that are clear, sets the right expectation, and also how to scale that over time. So I definitely agree with you.
I might, if it's okay, Alfred, my thought here too. Like I said earlier, I'm more on the infrastructure side, but this morning I was part of a program where we're providing education for folks who design the roads in Virginia, both in the private sector and the public sector. And the chief engineer from the Virginia Department of Transportation was there. The first question he was asked was, what are we doing to design our road to prepare for connected and automated vehicles? So I think it's not purely future. And for those of you in Virginia, in Northern Virginia, you can ride an automated electric shuttle that connects the I believe it's the West Falls Church Metro Station to the Mosaic District today. We're starting to see these being used, in this case more of a transit application. So I really appreciate your all's responses. These were fantastic. I've learned a ton. I'm sure all of our folks in the audience have. We have a lot of questions. I'm going to transition to asking you some of the audience submitted questions. And for those of you on the meeting, if you'd like to add more questions, please do so. So we're going to get through as many as we can. Let me see. Let's where should I start? You have answered this one to some degree, but I'll ask again. Will autonomous vehicles be more popular for commercial use before consumer use? Why or why not?
Well, I think it will be commercial first, but commercial in the sense where not like whether this is a ride sharing business versus a consumer owned vehicle. I mean, commercial in a sense where it's goods transportation versus passenger transportation. And the reason being, I think self-driving cars, the hardest three problems that we're solving is passenger safety, passenger comfort, and the public safety. And by not having to solve passenger safety and the comfort, you significantly simplify the problem to a certain degree. Groceries and pizzas do not really care about how well you drive. So that's a pretty big advantage. That's my view.
I think that's a great point. There's definitely the comfort issue, right? There's a safety issue, but then there's the comfort issue. And I think some folks even talked about the personality of the autonomous car, right? It could do everything right and be super safe, but maybe you don't like the way that it's driving. You don't like, the way that it does certain things. So should you be able to program it to have different driving styles or personalities? So I think that once you get a human in the loop, there's, the safety aspect, but then there's a subjective comfort assessment of it also that plays into the decision for somebody to adopt the technology and the product. On the safety side, though, what I would say is super exciting to me is that I definitely feel that our advancements in the autonomous driving aspect of the technologies have trickled into ADAS, which is advanced driver assistance, which is the safety features that come on a car. And so I do feel that by pushing the envelope, by investigating these automated and autonomous driving technologies, the ADAS features that we're seeing deployed on commercial vehicles are getting more and more sophisticated. You know, the standards that are coming with Euro NCAP, the new car assessment program, are getting richer every year. You know, they're now considering more advanced cross-traffic scenarios and safety for those, and a lot of things that you know, even 5 years ago would be difficult to imagine coming standard on a vehicle to improve safety. So I think from the safety side and the consumer side, there are definitely benefits that we're seeing as a result of the work that we're doing.
I'm on mute, I apologize. So another question that came in is the question was, is data storage on the cloud impervious to hacking attempts? Probably not, I think. So maybe to rephrase that question a bit, you know, what is the landscape in terms of security for autonomous vehicles?
Maybe I can tackle that. So I think that what's really fundamentally excellent about this question is tackling the infrastructure side. You know, so far in the conversation, we've talked about the machine, the car, basically the embedded system that is moving on the roads. But we have to remember, how do you teach that robot to do what it does? It takes a data center. It takes a full-on infrastructure, and that piece should not be underestimated. You know, you're importing that data and you're not just storing it, you're actually processing it and doing a whole bunch of other stuff that also needs security, along with the storage aspects of itself. And at NVIDIA, we've actually invested quite a bit on the data center side. So using compute, using networking, coming out with dedicated chips that do security. You know, I mentioned participating in standardization bodies. Security bodies are also among those. Cybersecurity bodies are also among those. So I think that 100% making that investment, knowing that up front, that this is what it takes to teach a robot, to teach your robot how to drive itself, you know, and we're investing in the technologies that do that.
So another question that came in is, what advice do you have for students who are interested in robotics and autonomous systems, but are taken aback by the many different academic and career paths that are out there? So in other words, what do we tell our entering UVA students as far as preparing for a career in this really exciting space?
JZ, you want to take that, or?
Sure, yes. Okay. I think this is an amazing time to be studying computer science, AI, and, you know, autonomy and robotics, you know, system. I think this is like the time when you saw breakthroughs in the last decade in machine learning, in compute, you know, sensors. I think this is probably the first time or first decade in entire history of humankind when, like, now we can truly build super autonomous and intelligent machines. So overall, I think it's like the best time to do that. I think in terms of career advice, I think it's a great way to learn, you know, by joining companies like NVIDIA and Nuro, either through internship or a full-time job. You know, I think you get to learn so much about the technical stack, about the industry landscape, and all the challenges that the industry is facing. And I think you know, there are a few companies in the industry where I think are leading, you know, both in terms of technology as well as in terms of commercialization. You know, I highly recommend you know, learning through you know, taking an internship or a full-time job there.
I would echo that 100%. I think that internships are fantastic. You know, it's a great way to take the coursework that you have learned to the next level, because now you are knowing what the real kind of behind the scenes gritty challenges are of the industry. You're becoming an insider, really, and so you're taking that to the next level. You're practically doing things hands-on. And I think that once you do something like that, you never unlearn it. You never forget it. You also really, I think, understand in a very practical and concrete way what you like versus what you don't like. And that is super valuable. You need to know what you don't like. What do you like about robotics? Because if you unpack it, going back to what Jay-Z said at the beginning, do you like perception? Do you like mapping and localization? Do you like planning and control? Do you like prediction? Even within all of these areas, there's like 10 sub areas, right? And even in that full stack, what do you like? Do you like middleware? Do you like operating systems? Do you like designing hardware? How do you find that out, right? And so I think that that's the key. Take the knowledge that you're getting in school and test it out in the real world and see what holds up and see where that takes you. So I think that is the best way. Just try and see where it takes you and what you love.
I think that's great advice, and you have to allow me to make a pitch here. We're so fortunate at UVA to have really active alumni who are looking for ways to support our students. And just for those of you in the meeting who are with companies with opportunities like this, please reach out to faculty, to folks in the Alumni Foundation, because it makes a huge difference for us to connect students with these internship opportunities. The one thing I wanted to mention too is that there's, as far as the ways to prepare for this industry, it's just, there's so many different paths that you can follow within UVA. There's going to be a need to rethink how we plan our transportation systems in our community. So in the architecture school, there'll be lots of opportunities there. Within engineering, beyond the computer science aspects, these are truly large scale complex systems. How do we design these systems to function together effectively? How do we design and build our infrastructure to support these vehicles? Sensing is such a huge issue. There's lots of issues there in the electrical side, for example. So, and then we can go to Batten and talk about policy. Policy has to be rethought for all of this too. So there's quite frankly almost nothing at UVA this doesn't touch. And that's, in my mind, what makes this incredibly exciting and to be part of. So I'm not supposed to answer questions. I apologize. I couldn't resist that one. I guess it's the teacher in me. So let's see. Another question here is, and this is, it's a long question, so I'm going to try to shrink it a bit. But that is about the issue that we will not have a fully autonomous system at day one. We're going to have a mixed fleet of some personally driven vehicles, some autonomous vehicles, and there's some concern that perhaps the safety benefits could potentially be oversold because you're going to be in a very complex mixed fleet. Maybe you all could comment on that aspect of how these vehicles will operate in a mixed fleet of autonomous and human-driven vehicles.
Sure. So I'd like to maybe make two comments on this one. One is, sometimes I think that we forget that there are tremendous benefits of even not fully autonomous driving. If you've taken a long road trip in California, 500 miles, and you just have to do cruise control and lane keeping for like 5 hours, that sucks, right? And so even a system that does that incredibly well is really excellent. I just want to point this out because this is incredibly valuable to kind of to remember that even a not fully autonomous vehicle can bring tremendous benefits, not just for goods transportation, but also to passengers. So that's the first thing. The second thing is that, we are of course aware that there's going to be a gradual transition. I just want to give one example in terms of safety. So at NVIDIA, we have a software module called the safety force field, which basically acts as a secondary checker on the driving actions of the primary planning and control system of the car. And it doesn't really care whether the primary planning and control system is a human or some algorithm. It works the same way. It works exactly the same way. And so by designing a software stack that's modular, where you could just take that software module and apply it to a vehicle, maybe as part of your ADAS suite of functions that's now compliant with some future version of NCAP, you now have a common way to check safety of a car, whether it's being driven by a human or not. And so I think that through ADAS and through designing this software in a modular way, there's things that we could do to ease safety along that automation curve. Because again, from the beginning, we know that it won't be something that turns on from day one, but we're planning for that effectively.
100% aligned. I don't have more to add here.
I have a final question for you. Is there more technical complexity in solving for aerial autonomous vehicles versus road-based? Why is Nuro starting with a road-based problem statement?
Yeah, great question. So the main reason for us to focus on road vehicles is when we think about the payload, when we think about the regulation pass, we really see that on-road vehicles for goods transportation will be there in the long term. But it's a bit harder to say that for drones, for example. So imagine, one day, right, when you look up into the sky and you see thousands of drones delivering, groceries. Everyone's carrying 3 bags of grocery. That's probably not the future that we want. I don't know if it's going to be super safe. I think drones are excellent for a little bit less payload, but super fast, super efficient delivery in areas where ground transportation is very, very hard to get access. Maybe this is a rural area, or maybe this is like super urgent document that you need to deliver in the urban area, or things like that. But I think from a payload and safety perspective, I believe ground vehicle will be there first, and at a larger scale.
I just want to say that I agree with Jay-Z. I think the key innovation will come in revolutionizing and improving the ground-based, whether it's passenger driving or goods delivery, overcoming some of the hurdles we've traditionally had through automation and autonomous technologies.
Great, thank you so much. I see that Brian is back with us. So thank you both for answering that final question, and I will pass it back to Brian to wrap us up with some final thoughts.
So thanks. So, and I noticed we had a mention from Kath Welsh saying having your host disappearing is ironic. Consumer confidence eroded. So I do apologize. I had a computer issue. I can assure you that having worked in this industry, that there's a lot going to deal with how these systems can have graceful degradation when things go wrong, because things will go wrong. So anyway, so I apologize for being gone for a moment. I would just like to conclude. We are out of time. I'm really thrilled that we were able to host this really insightful Cross Grounds event today. I want to thank Jay-Z and Neda for their time and their insight. And I want to thank the audience for participation and for asking such great questions. I know I personally have about 3 hours worth of questions more that I would like to ask, but I guess we need to conclude. So thank you very, very much. If you're interested in watching this webinar again or sharing with friends, the recording will be available soon on the UVA Club's YouTube channel. And I hope everyone has a great rest of their day. This now concludes our webinar. Thank you all very much.